Alright, here is the video guide for 1.2.3, focusing on the slopes of parallel and perpendicular lines. What is special about the slopes of parallel and perpendicular lines? That word slope should ring a bell from algebra. It's just a fancy way of saying rate of change of a straight line, or rise over run of a straight line, and we'll get more into that as we work through the lesson. And similar to the lesson I just posted, 1.2.2, I'm going to work through problems relatively quickly, and then if you have further questions or you want more explanation, just please shoot me an email and I'll make specific videos for specific problems. All right. In 168, we're looking at this image to the right, and it's just saying, what do you notice about the image and the line of reflection of the original triangle? What I notice is that they look like, or the triangle, sorry, has been reflected over the line of reflection. Okay, but more specifically, what I want to take a look at is how my diagonal counting method doesn't really apply. All right, because usually I could say, well, that's one diagonal and then a half. Well, that's not a half of a diagonal anymore, that's 2/3. So the other thing to notice here is that the diagonal counting method has failed. And so what do we do when the diagonal counting method has failed? And that's kind of the idea here. How can these slopes, or how could slopes somewhat help us with this? All right. In 169, we have our first look at graphing a line, which might have been since algebra, so we're going to do that here. The first thing we're going to do is begin by graphing this line here. Now, when I graph a line, I always start with the intercept, the y-intercept, which is -4. And so that means I start down at -4. And then I use my slope, which is, I said, rise over run, to build the line. So I go, my rise is 3, my run is 5, +3, +5. So I start at my starting point and I go 1, 2, 3, rise, 1, 2, 3, 4, 5 as my run. And there's my second point. I'll do it one more time. 1, 2, 3, 1, 2, 3, 4, 5. And I have my line being built. You could also see this as -3 over -5. So I could also go down 3 and then to the left 5. 1, 2, 3, 4, 5. I could build my line that way. I'm going to connect it with a line here. And I'll try to connect it down here. It's not going to look perfect because I just kind of stink a little bit at these sometimes. But then it says we need to use tracing paper, which we don't really use because we're mostly virtual, and we have to translate this line. We just learned about translation last lesson. It's just shifting it, and we're going to shift it up 5 units. Because we don't have tracing paper, what I'm going to do is I'm just going to take each point and I'm going to move it up 5 units. And so I go 1, 2, 3, 4, 5 for this one, and there's my point translated up. This one, 1, 2, 3, 4, 5 right here. This one, 1, 2, 3, 4, 5. And there I'm just going to be good with it, and I'm going to draw my line. And then we're going to evaluate. Okay. Try to finish it this way. Right there. All right. And then it says, what is the relationship and what is the relationship between the lines and its image, and how do the slopes compare? Well, 2 big things here. I believe that these lines are parallel. They look parallel. And so that's what I'm going to say is the relationship. And then let's look at the slopes. And so all I did was shift the line up. So my assumption is that the slope has stayed the same, but I'm going to create a slope triangle to check that. Slope triangle is just drawing a triangle from one point, a right triangle from one point to another. And so I go from here up to here. There's my right triangle. Now I'm going to label it as well. I'll do them both actually right away. And I'm going to label these triangles with the values that they're worth, meaning I'm going to say that this went over 5, and so that's worth 5 right there. And this part of the triangle is 3. This is 5. This is 3. because it went over 5, up 3. Over here it went over 5 and up 3. So I have confirmed that the slopes are the same, and I have also confirmed since they have the same slope, what that means for us is, and this is something you should write down and remember and study, that same slope means the lines are parallel. Same slope means the lines are parallel. I'll even put exclamation points by it because it's that important. All right, we'll see that again. This is not the last time we'll see that. Okay? And again, you can prove that same slope by making a slope triangle or just looking at the slope knowing rise over rho. Okay? Next, we have, we're going to do the same line, but instead of sliding it up 5 or translating it up 5, we're going to rotate it 90 degrees clockwise. So I'm going to make the same line. We start down at -4, so I go down to -4, and then up 3 over 5, 2, 3, 1, 2, 3, 4, 5. We'll do it one more time. Up 3, 1, 2, 3, 4, 5. And we'll make my line. Something like that, a little off. All right, and now we need to rotate this 90 degrees clockwise. And so we don't have tracing paper, which makes the rotation a little bit harder, but we can take a couple of points and we can rotate them. So what I'm going to do here is I'm going to take a specific point, this point right here, and I'm going to rotate that point 90 degrees. Now, that's not the easiest thing in the world to do, but if some of us with being visual, it is not the worst thing either. And so what I notice is that this point is at -1, +5. That's where that point is. Now I need to rotate that -1, +5 into this quadrant because I'm moving it clockwise. And so what's going to happen is where that used to be -1 down to here, it's going to now be -1 to the left. And where it used to be +5 going to the right, it's now going to be -5 going down. And so I go to the left, and then I go down 5, 1, 2, 3, 4, 5, and that's where my new point is. And what you can see is that moved from this quadrant into this quadrant. And that's what you kind of have to do. You have to take points in a certain quadrant and shift them to the quadrant either below them or to the left or to the right, depending on clockwise or counterclockwise. For this point here, see it's in this quadrant, we're going to move it counterclockwise, so it's going to move down to this quadrant. And that point is at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's at 10, +2. That's going to kind of flip, and so now it's going to be down at 10 and over at 2. And so there's going to be my second point right down here. I'm going to draw a line through it so you can see the line. Something here. Not perfect, but it'll work. And then it says describe the relationship between that line and its new image. So describe the relationship between these two lines. Well, these two lines are what we call perpendicular. Okay, perpendicular, what it means is that two lines intersect and they form a 90-degree angle. Those two lines would be perpendicular. Okay, so then the original line and the rotated line are perpendicular because they form 90, like I just said. Now we want to look at the slopes of both lines. So we'll make slope triangles to help me see it. We'll go over and up. And similarly here, we're going to go over and up. Okay, two slope triangles. Now I'm going to label those again so we can see it. This was over 5, and that's a +5 because it traveled to the right. And this was up 3. And so that is that 3 over 5 slope. Rise over rho and slope was 3 over 5. All right. This one here, two different ways you can think about it. We could go down and then to the right, or we could go to the left and up. We'll do down and to the right. So if that's traveling down, that is a -5. And if that's traveling to the right, that's a +3. So this slope right here, is, if I wanted to write it as a slope, 3 over 5. If I wanted to look at this slope right here, my text box wanted to work for me. Here we go. Oh, come on. Is because again, it's rise over run. 3 was my rise, 5 was my run. This time, -5 is my rise, or fall, technically, and 3 is my run. And so those are our two slopes. One is 3 over 5, one is -5 over 3. And so if we look at those slopes, what we can notice is that they have been flipped and one is negative. All right? Because that's 3 over 5, that's -5 over 3. And so if we're talking about a relationship, well, slopes are similar, but one has been flipped and made negative. The word that I want you to remember and the word that I want you to probably write down, and it would be the definition of what we see in these two text boxes, is opposite reciprocal. We can't spell, not an English teacher. So opposite reciprocal is the word that describes, that's the mathematical term that describes this relationship here. Reciprocal means that it's been flipped, which we see, 3 over 5, 5 over 3. And opposite just means that one has to be negative while one has to be positive. Okay? We're going to move on here. This YouTube video here, I'm showing you how to do slope triangles. This is further instruction from a video I found on slope triangles. If that idea confuses you, please click it and watch it. It explains it further because we're going to use it here in 170. Okay? So I put on here that I only want you to graph one line, and I want you to kind of practice this rotating idea, okay? And we already kind of did this in the first problem, but I just wanted it as another practice problem. I'm going to choose the slope of 1/3, okay? And so we're going to start at the origin, and 1/3 means up 1 over 3, so up 1 over 3, up 1 over 3, or we could do down 1 to the left 3, down 1 to the left 3 to keep our line going. And we can create our line. Now this is, again, a reason I picked this one is to practice our ability of rotating, because, like I said, rotating without tracing paper can be somewhat difficult. So again, this point was at +3, 1. That point is in this quadrant, and we're moving clockwise, so we have to move it, or counterclockwise if you want to, but we'll do clockwise again. If we want to go from this quadrant and we're going clockwise, we know that point has to travel down into this quadrant. And so if that was 3 up 1, now we have to go down 3 over 1. It just kind of flips them. So that was 3, 1, 3 to the right, up 1. This is now 3 down to the right 1. And we could kind of repeat that. This would then be up 3 over 1 here, and we can kind of start forming our line already. So I can draw my line here, and I see that same relationship as I did last time. Okay, so how does the slope of each line compare? Well, I'll draw the slope triangles again just to keep helping us see that. You go down 3 over 1, and on this one you go over 3 up 1. So if I write for my positive slope here, my slope that is traveling here, or this slope triangle, that is a slope of 1 over 3. For this slope down here, that is a slope of -3 over 1. Again, we get that relationship of opposite reciprocals. Can't spell reciprocal. Is that how I spelled it on the top one? Oh yeah, okay. So we get that opposite reciprocal relationship. Again, what that means is that reciprocal means that the fraction has been flipped, like 1 over 3, but now it's 3 over 1, and opposite just means that 1 is negative, 1 is positive. I have to make a second video, sadly. I wanted to go quicker. But the last thing I'll say in this 30 seconds is that if the line is going from left to right and it's going up, that's going to always be positive. If from left to right the line is going down, that's always going to be a negative slope. And that might help you remember which one's going to be opposite, and or which one's going to be negative, which one's going to be positive. And like I said, I'll make one more video, and it'll be short, and we'll finish this lesson out.